We're currently living in a technological age and the world is surrounded. We are wired with different kinds of programs. And in this video, I'm going to explain exactly this computer programming. And by the end of this video, you should have a comprehensive understanding of what programming is, what computer programs are, and then possibly the different types of programming language are. And hopefully you might even start writing your own programs and start writing your own. And to make work easier, the illustrations, I'll be using my XP Pen graphics tablet here. So let's dive into it. Okay, welcome back. And now to fully understand what computer programming is, first of all, we need to understand what a computer is, okay? So a computer simply is what a general purpose machine, okay? That means it can actually do different things at the same time, run different operations. But a computer cannot do anything on its own, okay? In order for the machine to actually work, what it needs a set of instructions. Okay, so we normally say that the computer is so smart, but actually it's very dumb, and it can do practically nothing without a set of instructions. Okay, so those instructions actually tell the computer what to do. And now the fancy term for instruction in computer science will be programs. Okay, so now what are programs? Programs are simply what? Sets of instructions. Okay, so this tells the computer what to actually do. Okay, when you switch on your power button, you're actually running a program. You're actually running sets of instructions. When you open your Microsoft Word, you are running sets of instructions telling the computer what to do, else it will not do practically anything. Okay, so programs are simply step-by-step sets of instruction that helps the computer to run a specific task. Okay, so now in the computer you can have a lot of programs, okay, that are doing different things. So it's like you have one program that can be responsible for the computer, or you have another program that runs whenever you open the Microsoft Word. So these are different set of programs that actually, once you do something to the computer, these programs are actually executed in order to work to achieve a particular aim or to perform a particular task. Okay, and then so we know that basically the computer only understands 0 and 1, not 0 to 1, 0 and 1. So these are what we call the binary, okay, binary number. Okay, so the computer only understands 0 and 1 and nothing else. Okay, and then what this simply means is that the computer, okay, so what this simply means that the computer has hardware, and then it has switches in it, it has transistors. Okay, so when there's a 1, it means that something is on. It means that one of the switch or one of the transistors is on. When there's 0, it means off. Okay, so now these are ways. It's like you're sending electrical signals. Okay, you're sending electrical signals to the computer. So once I click on let's say I click on the letter M on my keyboard, okay, I'm sending electrical system to the motherboard, to the central processing unit. Okay, and this letter M, it's actually interpreted as bundles of binary numbers. Okay, so because the computer doesn't understand what M is, but it understands what ones and zeros are, so this one is actually converted to 1 2 3 1 0. This is what they call the binary. Okay, it's converted to a binary number. So now this is what the computer is going to understand. Okay, it's going to understand that on off on off. This means that someone is actually pressing the letter. But then how do we communicate with the computer? Now this is where an interesting term comes into. So before I told you that a program is simply what um, a series or steps of instructions that tell the computer what to do. Programmer is a person who writes programs, okay? And now you need what you call a programming. And what now? So a programming language is simply a way of actually communicating with the computer. Just as human beings, we have different languages. Okay, so I can communicate in English, I can communicate in French. So French is a programming language. Okay, so but within that language, you have ways or steps of actually communicating different aspects. Okay, so the programming language is simply the whole package. It contains a lot of symbols and numbers and different ways of actually writing or actually speaking to the computer. Okay, so the programmer understands the programming languages and writes a program that is executed to the computer so that the computer can actually understand and do something. Okay, so you must have a knowledge of a programming language that the computer can understand. So now that brings us to the question, what are the types of programming languages that we have there? Okay, so basically the first one that we're actually going to start with is called the machine. So the first one that we're going to start with is called the machine level language. So what this really means is that you are simply writing zeros and one directly to the computer. Okay, so you are simply communicating to the computer in binary. Okay, in binary form. Okay, so if you want the computer to perform a particular task, let's say you want the computer to on, or when you press a particular key, and then so what you are simply going to do is that you're going to be writing a series of binary numbers. So this can mean the letter M. Okay, another one 0 0 1 can mean something else, like let's say on a particular program. Okay, so you are down, you are at the very low level of the computer where you're communicating to the computer directly in the language it understands. Okay, so the computer understands binary numbers, zeros and one. So you as a programmer that is writing the code, you are simply writing the codes in zeros and one. And the problem with this is that this can be very, very strenuous and very frustrating. Okay, so imagine where if a letter M, if this whole binary represents letter M, and then you have to write a program that tells the computer, let's say, to print out a series of letters. You can begin to imagine how complex or how complex that is actually going to be. And if you make a particular error when you are writing the program, it's going to be very difficult for you to find actual where exactly the error is. Okay, so now to fix these particular issues, another programming language setup came up. That was what the assembly. Okay, so the assembly level language. Okay, so now before, this could mean to the computer, this could mean to the computer 5 plus 6. Okay, so when I open my calculator and I press 5 plus 6, okay, the computer will interpret that and convert it to binary numbers and know, okay, this person is actually, this is a signal that is actually going to go to the computer, and the computer know, okay, this person is actually trying to say 5 plus 6. Okay, this is the machine level. But now when what we are trying to solve is that we are trying to move more away from the machine level and come more towards the human level. So you want to write something that at least a human being can actually understand and then communicate with the computer. Okay, so we are trying to bridge that gap between the computer and the human being and making it more easier. Okay, so now in the assembly language, this is where we started using a bit of letters, bit of characters together. So let's say, for example, as I said before, this would mean 5 plus 1. But now in assembly language, all you just had to do 5 and 6. Okay. Now, if you just write a programming language, if you just write a program and you enter this particular code, okay, add 5 and 6. What this means is it simply means this 5 plus 6. Okay. So when you run this, the computer knows, okay, this person is actually trying to perform this particular operation here. So I'm actually going to give the result out as what? What's 5 plus 6? Is 11. Okay, so the person is actually going to give you out as 11. Okay, see, so now we're actually moving towards that area where we're actually getting the understanding of it's becoming easier for us to tell the computer what to do. That's we are bringing in language that is easier to understand. But then you might ask the question, how does the computer know that, okay, add 5 plus 2 actually means 1000? So it uses a program called an assembler. Okay, so that's it. So an assembler is simply what converts this bunch of letters and numbers into the binary, and this is executed. Okay, and it converts it into machine language, and then this is executed and the computer knows, okay, I'm supposed to give out the answer 11 out. Okay, so that is it. So an assembly language uses an assembler to convert its particular code, as you can see here now, into machine language that is easily executed um, by the computer. Okay, the problem with assembly language is that if you write a program, if you write a particular program on a particular machine, you cannot run it in a different machine. Okay, so let's say for example you create a calculator for, let's say, a Lenovo computer, or any kind of computer, okay, out there. So if the architecture of the computer is actually different, the architecture of the computer might be actually different from a Dell computer. So the way the computer is arranged, the way everything has been arranged might be different from another computer. So it's going to be impossible for you to write, let's say you want to build a calculator. It's impossible for this calculator to work in this order computer. So it's like you have to write code for this and you write programs for this at the same time. So imagine the lot of work and the stress that that's actually going to give you. So that is where the third option comes into place. That is what the high level language. Okay, so now we come to the high level languages. Now these languages are more, it's more human like. Okay, so it's easier for us to actually understand what is actually written there. Okay, so in a high level languages you can have an operation like 5 plus 6. Okay, and then you run this in the computer and then you have your answer as 11. Okay, so now we are dealing with things that are actually easy to understand here. In an assembly language, you will have to do this: add 5 and 6. So this converts to a machine language, to a binary language, machine language rather, and this is executed. Okay, I have to print out 11. But in a high level language, you can write the operation itself, that is 5 plus 6. Okay, we are faced now with the same problem again, is that the computer doesn't understand what 5 plus 6 is, so now it cannot execute this. Okay, so this cannot be executed. So now what do we need? We need the same approach that we use in the assembly language, where we had an assembler. That's the same thing that we're going to do in the high level language too. Okay, so now we need a way of actually converting our code, that's our source code, okay, so into an executable code. Okay, so now in order to do that, now the aim is to convert this into a bunch of binary, with the computer can actually understand, okay, this person is saying that 5 plus 6 is equals to, I'm supposed to give a result of 11 out. So now in order to do that, now high level language has two approaches in order to do that. It uses two approaches. It uses compilation, and the other approach it uses is what? Interpretation. These are the two approaches it uses to convert the code you write, that is more human friendly, into a machine language, into a machine code. Okay, so now how the first uh, how the first method works is that if you have a series of codes, okay, let's say a series of programs, you have written an instruction. Okay, let's say now you're developing a calculator and then you have written all your lines of code. Okay, so this is your source. This is your source code. Now, the compilation method, what it does is that it uses a compiler. Now, what a compiler does is that once you're done with all your program and you said, okay, I think it's now time for me to execute the program. I want this program to run and work. I want to see how it's going to look like. And then what it does is that this compiler is a program on its own. It is launched. Okay, it comes with the programming language that you're actually working with. We'll come in depth into that. And then what it does is that the compiler goes through all of your code. Okay, it runs through all of the code, and once it has gone through all of your code, it creates an executable. Now it creates an executable code. Now this is able to run in the machine. Okay, what that simply means is now the compiler converts all your bunch of, let's say you had a code that says 5 plus 6 is equals to 10. If a person presses 3, do this, this and this, and that is all your lines of, you have written all your lines of code. Okay, this is your program, right? Okay, so the compiler goes through all of it, so all of the source code, and then creates an executable code and then run it in the machine. Okay, so now that is what a compiler does. This is one approach they use in actually solving the problem of converting your high-level language into a machine language. Now the other method is what? Interpretation. Now the interpretation works differently. The interpretation, let's say you also have your source code. This is the program that you have written, and then so that's your source code. Okay, so now in order for this to be converted into machine language, in order for it to be converted into machine language, you need something in between here. That's what is called the interpretation. Now, what that means, you need a program called an interpreter. Okay, so now an interpreter, how it works is quite different from a compiler, but they actually give you the same result. An interpreter, what an interpreter does is that it goes to your code, it goes to the first line of code, checks it out, converts that to a machine language, and run that code. Okay, if that is done, it goes to the next line, convert it. You see, goes to the next line, the third line, converts it and run the code. Okay, goes to the next line and run the code. So it goes through your code bit by bit and executes it one after the other. A compiler will go through all of your code and give you one bunch, bam, like that. Okay, gives you just gives you a bunch of your whole program runs like that. An interpreter does the opposite. An interpreter goes bit by bit, so it runs your first code, check everything, gives you the result, goes to the next code, check everything, goes so bit by like that. Okay, so this is the approach that high level languages and use in actually converting the language into a machine language. But we also have something called a middle level language. So now what a middle level language is, a middle level language is simply a blend of a high level language and a low level language. Okay, so now what are low level languages? Your machine language and your assembly language, they are categorized under low level languages. Why? Because they are able to directly communicate or have direct access to your computer, to the hardware, to the memory of your computer. That's it. So low, high. So the higher you go, the difficult or the less access you have to the hardware itself. So a low level language, if I run a machine language, quickly it goes straight into the hardware because I'm actually working in the very crude form. Okay, so now a middle level language has a blend of a low level language and a high level language. So it gives you access to the computer system itself, the hardware, the memory, and also has the features of a high level language. So it's easier to use, it's easier to write codes like that. So examples of programming languages like that, examples of programming languages that are like that, you have C, you also have C plus plus. Okay, so these are programming languages that are actually middle level languages. Okay, so they can actually go deep into the hardware, the memory. This is why mostly C is actually used to build operating systems. Okay, direct access to the hardware itself. Okay, and at the same time you can actually have the features of high level language, so it's easier to write codes. Okay, so now for high level languages, you have languages like Java and Python, Pearl. So there are tons, there are plenty, there are just a lot of them out there. So there are just plenty. Okay, for assembly language, you'll be using something like MIMS. Okay, so this is actually a programming language that you use in the assembly language. Okay, so this is actually a type of an assembly language, MIMS, that you can actually communicate with the computer. It's a little bit difficult compared with high level languages where you have Java, Python, and more are still coming, making life more easier for you. Okay, and then so now just looking at the speed of the programming language, a low level language, let's say a machine level language is going to run faster. Okay, so it's going to run faster than any of the programming language because you are dealing in ones and zeros, so the computer quickly understands it. You don't need any middleman in between. Now an assembly language is going to run faster than a high level language but slower than a middle level language because you still need an assembler that is actually going to convert that your code into machine language. Now a high level language is the one that it's slower compared with the rest of the tree. It doesn't necessarily mean that it's very slow. It means compared with the three level languages, it has the least speed of execution, okay, because it has to go through a series of process before it can actually convert into uh, a machine language. Okay, then so we're looking at it. So we can have now a let's look at the high level languages. So you might ask yourself, what kind of programming languages use a compiler? So the type of programming languages that use compilers are C, C++, Java, and the type of programming languages that use an interpreter are what you have languages like Python. Okay, that simply basically is what computer programming it's all about. I know it's a lot to take in, but as you go through it, it becomes easier to actually use. Okay, so that's it. So a computer can't do anything on its own. It needs programs. Programs are simply sets of instruction. A programmer writes a program based on a programming language. There are different types of programming languages. You have three categories. You have a low level language, the low level languages. Okay, so let's start with we have the machine level language. So the machine level language is simply what zeros and one. The computer easily understands this. You are communicating directly to the computer in the language it understands. The assembly languages uses a little bit of symbols, okay, to communicate with the computer, but it needs an assembler. An assembler is what is actually going to convert those symbols and those letters with a bunch of text into machine language. It converts it back to zeros and one. But this assembly language can't work in different computer architecture, so you're going to have a problem running it in different pieces. Okay, so now this is where high level languages come. They solve that particular problem, and then so but how do they run their codes? Because you're still writing code. The codes are much easier, it's more readable. 5 plus 6, you understand as a human being. It's you understand as a human being compared with 0 1 0 0 0 1 1 or add 5 and all of those things. Okay, so but now in order to convert that code in a high level language into a language, you need what you call, it has two approaches that they use. It uses a compilation approach or the interpretation approach. The compilation approach uses a compiler. What a compiler does is that once you have written all your code, it goes through all of your code. It runs through from the top to the bottom, and then what spits out a bunch of executable code for you. So now this is what's actually going to run, and the computer will understand it and it's going to run. So it goes through all of your code. The other method is called interpretation. The interpretation method uses a program called an interpreter. What an interpreter does is that it goes through your code line by line. So it goes to line 1, execute it. Okay, goes to line 2, execute it, goes to line 3. It's different from a compiler that goes through all of it once, okay, and then gives you a result. And then so that's it. So computer languages, the programming languages that actually use a compiler, you have C, you have C++, you have Java. For interpreters, you have programs like Python. Okay, so another thing is that you have languages called middle level language. Now, middle level languages are languages that have features of low level languages and high level language. The low level language are language that can actually easily access to the computer. The low level language is divided into two branches. That you have the machine level language and the assembly. Those two form the low level because it's easier for you to have access to the hardware of the computer. Easy, you can easily communicate with the hardware. The memory of the computer, you can access it very easy with assembly language and machine language. So now programs, there are certain program language that have both of these features. They have high level, it's easier for you to write codes, and at the same time you can easily access. You have programs like C and C++, they are pretty good with it. Okay, so like for assembly too, you have programming languages like MISP, so it does the same thing. You can easily access the memory, do some changes and configuration, all of those things. So that simply is what computer programming is all about, telling the computer what to do, and then but using sets of principles, sets of symbols and instruction. Those are converted and the computer understands it and then gives you back a result. Okay, so I hope you love this video. Please feel free to like the video, share the video, and please don't forget to subscribe. Till we meet again. Let me know your comments below. Is there any part that you feel that needs more explanation, or is there something else that you want me to explain more on? Okay, and we'll see you next video. Bye.